Okay, in this problem, we're going to be solving a radical equation. And just like the previous set of problems where we want to get a radical by itself and then we square both sides, that's going to be the same step that occurs here. However, when we square x plus 1, we're actually going to be squaring a binomial. So that's going to be a little different, and we'll see how that works. So here's our problem. X plus 1 equals the square root of 7x plus 15. So if we square both sides, we know what happens to the square root. We know that's going to go away. But over here on the left-hand side, we're going to have a little bit of a different situation. So remember, x plus 1 can really be expanded into, that's a perfect square, x plus 1 times x plus 1. And we can take away the square root sign over here. And if we FOIL that, x times x is x squared, and x times 1 is 1x, and 1 times x is also 1x, and 1 times 1 is 1. So this simplifies to x squared plus 2x plus 1 equals 7x plus 15. Now, this is going to look kind of like a quadratic equation because it really is. We're going to move all of this over to the other side, so we're going to subtract 7x and 15 from both sides of the equation. So we'll have x squared plus 2x minus 7x plus 1 minus 15 equals 0. So those cancel. And then we have x squared minus 5x minus 14. And now it's really a factoring problem. So we can factor or find the factors of negative 14 that add up to negative 5. So I know the factors of 14 are 1 and 14 and 2 and 7. And I know that if I have a negative 7 and a positive 2, if I multiply those together, I get a product of negative 14. And if I add them, I'll get a sum of negative 5. So that leaves me with the following binomials: x minus 7 times x plus 2. Now here's the thing. These answers will not always be correct, or one of these answers may not be correct. What you must do is you must replace, first solve these for x. So if I set this equal to x, I'll get x equals 7. If I set this binomial equal to x, I get x equals negative 2. But we have to replace those values into our original problem to see whether it satisfies both sides of the equal sign. So if I replace, I'll just do that over here. So if I take x, or replace x with 7, I get 7 plus 1 equals the square root of 7 times 7 plus 15. 7 plus 1 is 8. So 8 equals the square root of 49 plus 15, and 49 plus 15 is 64. So I know the square root of 64 is 8. So 8 equals 8. So I know that's true. Let's try the same thing with negative 2. So I'll replace x with negative 2. And I'll do that on the underneath the radical as well. So 7 times negative 2 plus 15. Negative 2 plus 1 is negative 1. And the square root of it's negative 14 plus 15. So negative 1 equals the square root of 1. Negative 1 does not equal 1. Not a solution.